Good afternoon and welcome to Network Management Operations, the NMOP working group. So good afternoon, good morning, good night. I see that there are some people online. It's late or early, so welcome to everybody. So I'm Benoit Claes and we have
Moi, Luca there.
met. So do you want to go to the next slide? So this is one of the first session of the week, and I see some people that are new to the IETF here, so it's a good time to mention a note well. As a reminder, or if it's new to you, by participating in the IETF, you agree to follow the IETF process and policies. If you are aware of any patents or patent application, you should disclose that or not participate in discussion. You acknowledge that written audio, video, and photographic records may be made public. Personal information that you provide to the IETF will be handled in accordance with the IETF privacy statement. On the next slide, there is a note really well that we intend to have those meetings in professional collaboration networking as defined by the IETF guidelines for conduct and procedures. If you have any concerns about that, you might talk to the ombudsman. The IETF strives to create and maintain environments in which people of many different backgrounds and identities are treated with dignity, decency, and respect. And we must not, in a nutshell, engage in any harassment while at the IETF meeting, and it will not happen during the week or in this working group. So make sure that you sign to the data tracker. This is, if you go to the IETF agenda, you see the little screenshot over there. You can click on the Meet Echo. There are two versions of it. One is the Meet Echo Lite, in which you don't share the audio and video because you are in the room. If you are remote, you could do that. If you want to discuss, you could join the microphone queue from a button in Meet Echo. If you're locally here, it means you'll be in the queue here and make your comment or provide your feedback. Same thing for the people online. There is also a tool called Show of Hands in which we could participate to surveys. The agenda, well, we've got 4 big topics as described in the charter. This is the agenda online here, any agenda bashing. All right, hearing none. On the next slide, this is like a brand new working group created by our beloved AD, Rob Wilton, for a couple of days, and he wants to say a few words about the charter itself. Yeah, we're showing new slides.
Does that work? That sounds better. Okay, so just a few words. I'll try not to take too much time. I want to say, first of all, thank you for everyone who's helped chartering this. I'd like to say thank you to the chairs for stepping up. We've got 2 experienced chairs here, so I think that's a really good start to help sort of set us in a good direction. Also, I'd say thank you to Thomas. The chairs appointed as the working group secretary, so he's new to this role, so help Thomas as you can, but I think that's great. I think Thomas will do a great job for this. NMOP working group is sort of it was sort of interesting in terms of trying to get this working group charter because it's a different style of working group than a lot of the regular IETF ones. And one thing that is sort of a slight twist to what we regularly see in IETF working groups is that this one actually has a deliberate aim to try and pull more operator input into the IETF process. So that's one of the things that this working group is intended to try and address and charter for the area of network management operations. So we were seeing operators self-organizing the previous IETF meetings and doing lots of side meetings and presenting topics and things. And part of that is to try and pull that into a better way into the IETF process so that they can actually get agenda time, get people into the room, have all the minutes and things and associated AV stuff that goes well with these meetings. So that was one of the part of the things. The other aspect in terms of the charter, and I don't want to go through this text, but I'd like to go on to like slide 3. It's coming up here. Yeah, so one of the things that's important in this charter actually is that we have a focused list of topics. So we have some things that we said like in rough priority order. And so in terms of the sort of topics it's focusing on, it's really about trying to, how do you help better deploy existing network management technologies. So when you're finding issues as the operators try and deploy IETF protocols, how do they actually address these issues? In some cases, those can go back to the working groups and things and developing those protocols. But in other cases, we have issues that are more wide spanning across that, and we want to have an area, we want to have discussion of those issues and find potential solutions. And part of that, when we have these discussions, may be running short-term experiments as driven by the operators in terms of this is how we think of deploying this, and be able to do those experiments and then report back to this working group and get feedback on those experiments, like what things are going well, what things need changes, and then evolve those experiments over time. But the focus here is these experiments are short-term things. It's not like I would like to do something pie in the sky, 5 years, 10 years down the line. That's for IRTF. And it's also not really the case that it's meant to be for, I want to develop a brand new protocol. If you want to do that, then use the standard BOF process or a standard charting, work group chartering. This is aiming about how we make the existing protocols work a bit better and tweak them and drive that change in. Some other things we have in here is sort of discussing use cases and requirements. So that again is useful, and again will feed into other working groups. In terms of protocol work, this working group isn't chartered to do any protocol work at this stage. I tried to get it in the charter to allow it to do it, but because there's nothing on the charter to say there's actual work, I got pushbacks. It's been taken out, except for doing Yang models. But that is still an open door for this working group in future. If there was some small amount of protocol work it needed to do, that could happen here. But anything large would go to a separate working group, either an existing one or a new working group. What other comments have I got? So I think it's probably worth saying what is out of scope of this working group. And so long-term research ideas, that goes to NMRG, that's not to come here. And it's also not planned that working groups that are existing elsewhere that are closed and have like a tail end of work, the plan is not for those to come here, even if they're network management operated or focused on that, unless they're getting strong deployment and it's sort of deployment operator issues that are coming up. I think that sort of covers everything I have. Oh, and the last thing I want to say is the other thing that's sort of different with this working group is that it has a set of topics that it's going to aim to focus on. And at the moment we have 4 particular topics, and that's chosen by the working group, but with particular strong operator input into what the particular interesting topics should be, and with an AD oversight in terms of helping to choose those topics. So I won't be doing that, not for 3 days' time, but so I'll fall onto Mahesh, but to try and sort of curate and control what the list of topics are. At the moment, we've got network Yang push integration. So Thomas has been driving quite a lot of that work so far, and let's sort of bring that here. And again, some of the actual work is happening in other working groups, but the coordination activities and progress will be reported here. Anomaly detection, incident management are 2 things that have been coming up over the last sort of 1 or 2 meetings. So there's coordination in that area that will happen. That I think will be an interesting topic. We've got a digital map, which is about how to deploy the existing Yang topology modules, and in the process of trying to deploy those modules, finding what issues are arising and ways to fix them. Some of those base models were, for example, standardized in I2RS, which is no longer there. So again, this is the home to try and find a place to fix that. And then the last topic we've got currently focused on is an update to RFC 3535 BIS, which was an IAB workshop looking at the requirements for network management. So the interesting with that one is it was an IAB document, so we can't directly publish a BIS to that because we're not the IAB. But I think what the interesting bit of that area in this working group is to figure out what to do next is, do we ask for another IAB program to do the same thing? Do we want to reach out for operators directly from this working group? What is it we want to say there, and what do we want to do? And from the IAB side, Wes Hardaker, we discussed this in one of the IAB ISG meetings. He's got an interest in this. He was involved in that document 20 years ago. And so from an IAB side, he'd be a good contact person to help in that area. And I think the last thing is these topics are not fixed over time. They can change. And again, it would be like Mahesh and the chairs and the working group that decide what those topics are. But at the moment, it's trying to focus on a smaller number of topics and making progress with those and giving a decent amount of time to each topic. So I think I've probably used up enough of your agenda time.
Thank you.
Okay. Any questions before we move on? Thank you. Good luck.
Thank you, Rob, for the clarification. So we discussed the four different topics. It's time to cover the first one, which is the netconf yang push integration with Med. Please come here, Thomas. We try to focus together like what we expect from the session. In this case, this is to try to understand, to understand the problem statement and to see how the different documents are linked.
Good afternoon, everybody. So this work we started at IETF 115 in London, and where we kicked off, and we had several side meetings, and I've been asked to create an overview document so that the IETF community better understands how the individual drafts are related. Let me start describing what is actually the motivation, the driver behind it. So we have with Yang in RFC 7950 modeled configuration and operational data from the networks, and we have operators which are organizing the data in so-called data mesh or in data lakes. And today at the network operators, and I have been asking around the industry, quite a few of them, when we are subscribing to new Yang data in the network, usually it takes time until the Yang data can be visualized to the operational people. And the reason why is because it needs manual post-processing. So basically we cannot have an automated data processing chain, and therefore that's slowing us down. So this is a bit to show where we are in the industry. So I think the data industry is very well advanced in terms of modeling data, while IETF is, I think, doing a pretty good job in this area. And we need also to bring now this in the, let's say, the operator and the vendors. So yes, we want to have an automated data processing pipeline. We want that IETF is defining for the operational metrics the semantics. We want to generate in the so-called analytical metrics so that we can gain insight from the operational metrics we are collecting from the network. Important for us is that the metrics being exposed from the network should have proper time stamping. So that means not when the network event has been exposed, but when basically the change in the network has been observed. We want to make sure that we know from which network node, which process, basically the metrics have been exposed from the network. We don't want to change that along the data processing pipeline. So already have that information right at the source where we generate the network metrics. We want to forward the metrics unchanged from the network because at the very end, we're going to use those metrics not only to generate the analytical metrics, but also we want to close the loop. So whenever there are changes in the data processing pipeline, we no longer be able to, at the end, to close the loop. And also it will lead into problems on the data mesh side when we do the integration among different toolings. And at the end, controlling of the semantics is important whenever our data processing chain is allowing non-backward compatible changes in the semantics or not. This is the overall architecture. There are several components. So we have on the very first part, basically there where we do the Yang push subscription. From the network node, we are actually pushing the metrics. We are having subscription state change notifications informing the Yang push receiver that we have a new subscription. And from there, we can discover, based on what have been subscribed, what are the Yang models and what are the related or augmented Yang models, so that we have, from a semantics point of view, the right information. So that further, when we are pushing those matrices toward Apache Kafka, which is a message broker, that we can actually use the Yang modules, the semantics from the network, which we have previously registered in the Yang schema registry, so that we have a possibility when we are consuming the metrics from Apache Kafka that we can validate the message from the network against the Yang semantics. So that allows us to make sure that we can controlling not only the data processing pipeline, but also using the semantics, the Yang modules for creating at the end the table in the time series database or in the stream processor to import the data automatically. So with that, we basically enable an automated data processing chain. To give, while implementing this chain, we identified some gaps in the documents, and I'm going now through one to one. So we noticed that in the netconf notification, which is described in RFC 5277, that the notification part has been described in XML, but has not been described in Yang. So therefore, we lack the possibility to encode in JSON and in CBOR, and this document is addressing this shortcoming. Then in the subscription state change notification messages, we are adding two additional information. One is not only the filter, so the XPath or subtree filter, which has been applied, but also now having the Yang module name, revision, and revision label. So the revision label is the semantic versioning. So that we clearly understood also when the device is being upgraded and the models are changing, that the Yang push receiver is able to learn these changes. And then we have the support of hostname and sequencing so that we know exactly from which network node this has been pushed from, and the sequence number gives us a unique possibility in the data processing end-to-end change to identify each and every single message, and basically recognizing how much delay or loss we have, which is important because we are in the real-time data business here. Then in the push update and push change up notifications, same again, adding the hostname and the sequence ID, and also the so-called observation timestamping. So the observation timestamping, we have two different timestamping options, one for the periodical subscription. So that's the moment when basically the information on the Yang publisher is being pulled on the Yang data store, while on the push change update notification, this means basically when the event change happened in the network. And there we are having two options. One is basically if we are using the on-change subscription with the anchor with the sync on start option, and one without. So with sync on start option, the timestamp means basically before the Yang push subscription has been established, that we are able to see the initial state change in the network. Then we have identified that the Yang library is missing the capability to declare from a Yang module whenever this has been augmented by another Yang model, so that we can actually see the relationship of a Yang model in both directions. And
2 minutes left.
Yeah, thanks. And then last but not least, this is a new document which will be in this IETF being presented at NetMod. So in the XPath and the subtree filter, we are basically identifying the subscribed content as any data. So we are actually losing the semantics, and this document is describing by using Yang library how that content can be actually validated. Yeah, key is also we need to collaborate. We're gonna see in the data processing chain, there are several, let's say, components in it. So we have draft working on the Yang push side. We have also software developments needed on the Apache Kafka side itself, on the schema registry. And we, of course, need to collaborate with the analytical vendors as well, who are developing the time series databases or the real-time streaming processors, to make sure that what we are doing here is also properly integrated in there. These are, in a nutshell, the milestones. These are the open points. The first one have been addressed in this document, which is presented at NetMon at this IETF. The very last one, there is a hackathon. We had a hackathon project which was addressing this. And the second one here, I would really welcome feedback from the NMOP working group. First of all, is this an issue? Can you confirm this issue, and whether this issue, and how should this issue being addressed? I think that's it. So, so in a nutshell, this document is describing the architecture and then the motivation with the milestones and the open points. Do you agree that having Yang push natively integrated in Apache Kafka helps the operator to have an automated data processing chain? And do you agree that in the described linked documents for Yang push and the Yang library, that these shortcomings are addressed properly? And I think we have questions.
Thank you. Yeah, we've got Nigel.
Yeah. Hi, Nigel Davis, Sienna. Couple of, well, 3 points. This is good. I completely agree with your timestamp thing. I think there's been some very poor timestamping in the past. You mentioned semantics. I don't think there's sufficient semantics in the Yang models in general, and I think we need to go deeper. And we'll find that as we move along. And the final point, which I wrote down, fortunately, because I knew I'd forget it. When you talk about unchanging data from the network, have you thought about engineering when you get bursts and peaks where there can be a massive overload of data for if there's highly dynamic changing and so on, where you then need to potentially push back on the data, potentially moderate it a bit, maybe average it a bit more and so on. So it may need to change in some ways under those load circumstances, because solution engineering is really important, obviously. So.
Right. So on the third point, it was for us very important that at NetConf we have two transport implementations, one based on UDP and the other one based on HTTPS. So we believe that for accounting metrics, basically loss is perfectly fine. Yeah. So we want to have it pushed over UDP, where basically state changes in the network preferably would be transferred and retransmitted through HTTP.
Yeah, just on that state change, again, you can potentially, if you have rattling things where the state's going up, down, exactly. Something like an intermittent indication might be better than an infinite number of state changes. So you might want to look at things like that to, as I say, just to process it a little bit, so there's change. When the detail's irrelevant, but that there's change is important. But that they might be interesting things to look at as well.
Absolutely.
Okay.
Thanks.
So Rob Wilson, Cisco, without my AD hat on. So I think this is a good start. I think this is a great document to have. I think I was pushing you to write something like this, so not surprising. I do owe you review comments and things, so I'll send those through to you. But this is something that I think will be a good document to progress.
Good. Thank you.
Chin.
Thomas? Yeah, this is Chin. And the comments I have is, so in the slide you mentioned the operation metric and analytics metric. So can you give an example of this in operation metric, how this is different from the KPI metric? Maybe this is KPI metric associated with some kind of timestamp, or maybe it's the metadata you mentioned.
So I'm using the terminology from the data mesh architecture. So basically operational metrics is what you're collecting, and analytical metrics is what being generated in the analytical stack. So KPI metrics, if I use the term SLI and SLO, so basically both are, in my opinion, analytical metrics. So basically SLIs are derived from the operational metrics, while SLO basically you put the intent, the objective into context.
Yeah. So I also want to ask you in this you really gave a good picture how these different things put together. So, but you list a lot of extension, Yang push, Yang library, and Yang enhancement. So question for clarification is for this Yang enhancement is protocol extension or is young data model extension.
So can you repeat again?
Yeah, for this young enhancement,
Yeah.
I just want to make sure this is a protocol extension or this is a, young data model extension.
So, so there are extensions in the netconf notification header, in the Yang push header, but also there are extensions in the Yang library so far. And besides that, there is some, let's say, integration work in Apache Kafka itself, so that we can actually validate whether all those extensions we are doing on the network side works as intended.
Yeah, thank you.
Sure.
Thank you. Thank you, Thomas.
Thanks as well.
So this is an important work. We know it's going to link all the other documents that, by the way, are going to stay in NetConf. We know it's going to be a work group document spend time. This is a brand new document. We believe it would be good to get some more reviews. The one from Rob, I've got some feedback as well on the mailing list as soon as possible before adoption. And Ken, the queue is closed. Feel free to send your feedback to the mailing list directly or the chat.
Very good. Then I go to the next two documents regarding network anomaly detection. We've divided the slide deck in two areas. One has to do with the semantic metadata annotation, which we initially presented at NMOP and IPG at the last IETF. And now we have also another document which is about the network anomaly life cycle, so the refinement of the network anomaly detection system. So what it is all about, so when we say network anomaly detection, we mean monitoring VPNs, so connectivity services, and we're looking from three different perspectives in the control plane, forwarding plane, and management plane, as described in RFC 9232 in the network telemetry framework. Important to understand is we have basically southbound, we are collecting network telemetry metrics. This is covering different analytical use cases. One use cases which I'm describing here is network anomaly detection, which I will describe in the following slides in more detail what I mean exactly with this. And then northbound, we are generating analytical data, and there are two kinds of analytical data which can be generated. One are basically alert messages. So we want to inform the network operator that something happened in the network and we might be concerned about the changes in the network. And there we have, in terms of Yang, RFC 8632, how alerts being modeled. And we have the so-called post-mortem life cycle. So we want to make sure that the symptoms we are detecting with network anomaly detection, that these symptoms are properly labeled, that's the semantics draft, and that we are able to actually refine the network anomaly detection system, and that's the life cycle draft. So our motivation is obviously we are at the beginning with network anomaly detection. We want to learn and improve. So we want to reduce the false positives as much as possible. With more incidents in the network, more post-mortem, more refinement work in anomaly detection is needed. And therefore, we also need to automate this process. And the other thing is, one network operator doesn't have enough incidents. We would like to exchange the data among different operators and also academia. And therefore, we want to standardize the way how we are labeling the data. This is just an example from a post-mortem within Swisscom. So we have, like usually in the first slide, we are describing what are the operational metrics we were able to describe the incident in the network. While in the second slide, this is basically the generated analytical metrics, so how the system observed the incident in the network and how it was scoring the different checks. And here, by the way, at IETF 117, at the Applied Network Research workshop, the architecture of the network anomaly detection system has been described. So there is a paper available in case you want to know more about it. And then we're drawing conclusions at the end. And the conclusions can be manifold. So here we are proposing to current drafts in the GROW working group changes or enhancements which would have been contributing to this network to detect this network incident. And on the other side, there are also enhancements on the anomaly detection system or also on the network nodes or bug fixes needed there. So in case of labeling the data, describing the symptoms, we came up with three, let's say, in three levels. So action, reason, cause. So action is basically what actually happened in the network. And then the reason is basically describing why that action is happening, and the cause is actually why this reason what was being chosen. So basically, it should help towards the root cause analysis, and it should help in describing it not only to a human, to an operator, but also when we are exchanging the data with another system. In anomaly detection, we differentiate between mainly between three different kind of outliers. So with the symptoms, we need to describe what kind of outlier it is. A global outlier is like if within that time frame this was like a peak, an exceptional peak, or in a contextual outlier, this is related to a specific point in time. So for instance, if you have so-called missing traffic at 3 o'clock in the morning, this compares basically 3 o'clock in the morning to a previous day or previous week, for instance. While collective outlier here, the reference is to another time series. So for instance, if you have a drop spike in the forwarding plane, this could be related with the topology change in the control plane. That's the Yang model, where we see basically the symptoms, also describing the outliers, and also the reference to the system who is actually tagging the information. That would be the first draft. The second draft is, as I said previously, about the life cycle itself. Here, we need to be able, once the data is being properly labeled, as described in the previous draft, we want to make sure that we can actually work with that data. And in this experiment, we created this life cycle. So we go from detecting the network anomaly, tagging it with symptoms as shown, and then go into a validation process, which can have the network operator in the loop, and then refining the system and going back and replaying the data. So really important is to record the operational metrics. So by changing or refining the anomaly detection system, we can slowly basically improve the quality of the detection mechanism. Going a bit more into detail, how the workflow process is going. Here I want to highlight basically the relationship towards the incident. So we have basically in the detection state, we have either a forecasted incident. So we assume it will be happening in the future. So we see, based from past data, we can see a trend into the future, or we have detected right now in near real time a potential incident, and moving then in the validation state into a confirmed incident or not. That's the Yang model, where we are describing in this workflow the various steps and also linking the symptoms against. And here an example implementation Vincenzo and his colleagues were doing during the IETF 119 hackathon. It's called Antagonist, by using Grafana as a front end and having a time series database, in this example InfluxDB, in the backend. And then through a REST API, the front end can interact with the back end. This is just an example how labeling of data looks like, how the matrix are being tagged, and then at the end that you can have different versions, like you could have the same anomaly detection system, you're doing several cycles with refinements and tagging then the data differently and comparing them. Yeah, I see Rob is already in the queue. Maybe before I summarize.
So I just had a quick clarifying question. So when you said about replaying the data, is that you're effectively taking the data out of the time series database and then feeding it through your detection system?
Exactly. So basically, once the data is being labeled and identified to be a potential anomaly, then not only the operational data, but also the metadata together is being stored separately. And then you can do a refinement in the anomaly detection system and basically replay that previously recorded operational data and see how the detection system would be now different than before.
So where's the anomaly sort of classification done? What point is that being done on the device, or is that being done off the time series database?
That's being done. So if I go back. So we are receiving from the network the network telemetry data, and then the system is consuming that data. So it's usually like it can be stored in a database, can be a real-time streaming processor. You're querying or you stream the data, doing the detection, and then generating northbound the alert on one side, and the other side is basically the event for the refinement of the anomaly detection.
Because my gut instinct is that the records you're creating to classify the anomalies is going to take quite a lot of iterations to get that right.
Exactly.
So, and you want to be able to ideally be able to iterate it, and then obviously check it. As what you're saying, can I replay it and get a better refinement? But I think it's not just in terms of how you interpret it, but also how you do the labeling of which bits of data.
Exactly. So the main point is, I mean, if we do a refinement for a particular incident, you want to make sure that the previous recognized incidents or anomalies basically you did not make the system worse. Yeah.
So unit testing of the anomaly.
Exactly.
Anomaly detection. Yep.
Exactly.
Okay. Thank you.
Sure. So to conclude, so on the metadata, the annotation, we would like to have feedback from the working group. Is the structure which we are proposing valuable? Does it make sense not only for the human but also for the system itself? We see possibility not only to refine the system, but actually use that data also for going towards supervised machine learning. So now we have labeled data. Then on the second document on the network anomaly lifecycle, do you resonate with what has been shown in the diagram, how the workflow works, and also does it make sense to describe it that way in a Yang model? And also, are you able to see the difference between the alerts we are generating, the messages for the network anomaly lifecycle, and then later on also the work we are doing with the incident, network incident? Good. That's all from my side. Thanks. Thank you.
Any feedback on this specifically from the operators? Does it make sense? This is the question that Thomas asked a couple of times. While you go on the mic, I've got maybe one question regarding the maturity of this experiment, right? So I'm trying to understand. So you had the first draft for which you had like 2 hackathon coding sessions, and the second draft, which is new, was just one hackathon. So it's the first statement that this experiment is slightly less mature than the other one on Young Push. So how would you evaluate that?
Exactly. So the architecture for network anomaly itself, detection itself, I would say we are quite mature. It's about we have 1.5 years of experience in production network. While this work, how to do the labeling and then later also the refinement on the life cycle, this is something which we recently been working on. So it's not that mature yet.
Okay.
And I think the main point here is, we want to get feedback from other operators and start actually to come up with a more general solution for everybody.
Very good.
Thank you.
There are two people in the queue. Vincenzo.
Yes, sorry guys, can you hear me okay?
Sure.
Yeah, just wanted to add a small something very small to the answer that Thomas just provided. I think this work, especially the life cycle part, this might be very useful in terms of active learning, which is a branch of machine learning, which is exploring the ability of combining the creation of labels both from humans and AI. So that's also something we are currently exploring as part of this experiment. And it's going to be crucial to combine what we've seen so far with some real data from operators. That's going to be the key for the experiment as well.
Exactly.
Thank you.
This is Luis from Telefonica. So I think that the work is very interesting for sure. All the labeling and so categorizing the data is for sure interesting. So I was wondering if how far we can go in the direction of integrating other data that could be the one coming from active probing, T1 protocol or things like that. And also even some other sources like Syslock and these kind of sources. So talking with my colleagues in some of the operations, they are doing this correlation between the different sources, and then with that somehow going one step beyond and detecting impacts and doing some forecasting of some prevention, predictability of the situation. So, but my question is that how far we can go in the direction of integrating other sources for these incidents?
We kept the architecture pretty open so that we can also do other use cases. Actually, right now, Alex Huangfeng from the INSEAD University in Lyon is doing an internship at NII, and he's discovering that basically that this can not only be applied to layer 3 VPN services, but also on internet, on BGP AS use cases. So. And we observed that the architecture is pretty flexible.
Okay, thank you. Interesting, thank you.
Thank you, Thomas.
Thanks.
So the next one is on incident management. I believe we start with the terminology first. No? I believe that I don't start with the terminology first. So Chin, feel free to come to the microphone.
Yeah, hello everyone. Good afternoon. My name is Qing Wu, and so thanks Robert to set a background for this kind of work. Actually, yeah, based on suggestion, we move this work to NMOPs. And next.
Chin. Oh, and speak closer to the mic, please.
Okay. Yeah, recapture a little bit on what problem we really want to solve. Actually, with the growth of the service type and the network scale, the network management system usually need to deal with large amount of the data. Could be the KPI data, alarm data, trace data, and this data can be exchanged very frequently. So this really put more pressure on the management system. So traditionally we use management system may use some kind of data pricing actually can reduce the data to be reported, but it is time consuming and also labor intensive. In addition, actually, we actually need to consider integrate different data sources. Actually, you connect the KPI data, trace data, and log data, and but this usually managed by different system. So the problem we actually see is how you can analyze, the alarm data, KPI data, trace data, the service impact on the service, the impact on the service without, consider, the correlation with network topology data or consider correlation with different layer. So the mechanism we propose is a young data model, and actually really, define this young model for network incident management. And so the big motivation is to reduce the burden caused by transition network fault management. And in addition, we think we actually can work together with upper layer OSS, allow OSS to invoke IPC. For example, you can do the incident diagnose or incident report, and so we can build the closed loop to better, fix the problem. And also, we want to extend this kind of worker from single domain to multi-domain, so we can have end-to-end network management. So we can support some multi-domain, multi-layer use cases. For example, packet object integration. The case. So you can see the detail in the draft for the use cases. And so how to position this network incident management in this whole architecture? So we can give this, example architecture. We have, customer layer. We have service orchestrator layer. We have network controller layer. And so these, form this kind of hierarchical controller. And, the network controller, can be the, domain controller. They manage all the devices in a single domain. So the, network incident management, Young actually will be used on top of, network controller. And so they can work together with, L3NM, L2NM, and also network topology. So we can, better, establish, the relationship with the network topology or and various different service type. And so on top of service orchestrator, actually, there's some, TMF related specification. Actually, they define the, TMF API profiler. And we actually can work together with these TMF documents. Actually, you can see this TMF API provider really, define some kind of, incident, this troubleshooting incident. Actually, for this network incident, Young actually have to realize this troubleshooting incident. So you can see in the draft, actually, the model we define actually include, 3 IPC, 1 notification, exchange between the service orchestrator and the network controller. So these, really used to realize, incident function requirements defined in the TMF documents. In addition, incident parameter we define also, align with the TMF. And we also use actually TMF terminology at the kernel stage. And so actually based on,
I don't know if do you have a clarification question, or is it, yeah, because we have a Q&A section at the end of the 2 slots. So if you, that's why we close the queue. But so if it is clarification, you can say right now. Otherwise, we can wait later on. Yeah, that's on purpose.
Yes, Mahesh. So my question is more a clarification question. I'm still a little confused between the relationship between anomaly detection and incident management. Who's feeding data to whom, or if they're even exchanging data at all, where are they together in the stack?
Yeah.
And are the two drafts even talking to each other about how the data is supposed to be exchanged?
That's a good question. We actually did discuss a little bit. You can see this figure. Within the network controller, we have take a different data source. For example, trace data, simpleton data. The simpleton data actually, already, become the RFC. Actually, we can use this simpleton data, generator, incident data. But how you can, to translate it, you may use AI or use some other. This is leaves the out scope. Could be, document in Thomas' job, or maybe, yeah. I do think this is something need to better clear. But in the draft, actually, we do have a section to discuss the relationship with symptom and related worker. Yeah.
Yeah, Thomas Graf as a contributor. So you see here on the diagram alarm, the RFC 8632. So the network anomaly detection system is actually raising an alert. So alert could come from the network itself or could be coming through observed metrics from an anomaly detection system. And I think Quinn is describing the entire incident handling here.
Thank you. Yeah. Next, actually, based on this job has already put forward adoption in the OPSWG, and we have one comment related to the incident terminology. And I think this is joint presentation, so Nadia will give a detailed answer for this. So the question is, do we redefine this incident that really derive from the TMF? Actually, we gave two terminology we used in the draft. Actually, just a reference TMF work at the current stage, and also actually we contact TMF author about this, and they confirm from the TMF organization, and post the email to the OPSWG and NMOPs to confirm this term is aligned. And for more discussion, I think Nadia will can kick off. And so document status, this draft already presented 3 times, and first presented in actually net mode. Actually, we get a feedback, how this relate to the trace context related work, and we actually did address this and added some section to discuss this. And also we have 2 presentations in the OPSWG, and also organized a signing meeting in last IETF meeting to explore network incident use cases and missing pieces. And so we got a few good comments. Actually, all these comments actually addressed in the latest version. So the current status, already, for in the OPSWG, and get sufficient reply. And yeah, but the basis chair the AD suggestion, yeah, it should be moved to the NMOPs because they more fit into the current this charter. And so the latest version, actually we made several changes, rename the draft name, and second is narrow down the scope, make it more focused on young data model worker. And also we defined 2 young model in the origin job. Actually we consolidated into 1 because for incident type only used in this draft actually. And also we address 2 comments, one raised by Joe Clark, and another is from Li Zhenqiang, actually, yeah, to put some text to clarify. So yeah, for next step, actually, I think we want to request the working group adoption for this worker, and also to proceed this worker, we think maybe set up a design team to see how terminology can be aligned, and also regarding how to align with TMF, I have 2 proposals. The first is maybe NMOPs working with chair can send the to TMF to see how terminology can be aligned. Second is maybe, yeah, we can consider whether the formal relationship with TMF is really needed. Yeah, thanks.
Thank you.
Should I stand here?
After the presentation.
So we'll discuss the 2 drafts together in a Q&A. So please, Nigel, feel free to come with terminology, and we'll have an open discussion.
Okay, thank you. So we got an action at the last IETF to help stabilize the terminology in this. So we've taken a shot at that. And you can take a shot at us, of course. The critical thing, clarity of definition, consistency across all the documentation we have on incidents and various other things. So we actually have opportunity to port information from one to another and understand the terms in the same way. So we use key terms in the same way, have a common understanding of these terms, and have a single common definition, which we keep separately, I think is the important thing. So we need to keep a small set of terms. We didn't want to go into sort of every possible term we might use, because we ended up with, when we started, like 50. So we cut it back to many less, but we might find we need to expand it. Simple definitions. So we try and make them good dictionary-like definitions. Not, I notice often definitions go into wordy things and they start describing examples before they've even actually defined the term. No dependent terms, critically, undefined. So we make sure we define the stuff properly and not circular. Well, of course, all definitions are eventually circular because they have to be defined in terms of other terms. But we don't need all possible terms, and we don't need very detailed explanations. That's something that comes out of the drafts as they get the other drafts as they go and work through the actual use of the term. Would help to be consistent with other SDOs. We've looked at some of the terminology from TM4 and we weren't overly happy with the terms that were there when we looked at it from a sort of a pure perspective. So we might want to help. And again, the liaison I think is very important there to help sort of align the terms. We may find when we look at the draft that we've taken a particular set of definitions to the terms. We may decide to use the words in a non-English way in the way we're working here. So we may say, well, in this work, we mean this. We certainly found that challenge in inventory, where the term inventory it means list of stuff, and we use it completely differently in the group. So that's not bad as long as you define them very clearly. So it's a first attempt. The revision we got here, as I said, we sort of did a little bit of work on it, refined, and then we've published it. So you can now take shots at it. We've already got some comments, so obviously we'll refine further. We suggest that the definitions, we'll adapt the definitions to fit the comments, and then we need to go through some more serious review of this so it's actually solid and we've got a good shared view. Think about the scope of this, and certainly again it's drawing the boundary around what we're doing is critical. So incident is a very broad term, applies to very many problem spaces. So network only, do we need to look at security, other applications, not just network considerations and so on. So as we go through that work, we can sharpen the stakes, we can sharpen the definitions and get clarity around what we intend to apply them to. So the definitions we actually put in place, we decided we had to put some contextual ones in place initially. So resource, state, condition, change and occurrence were sort of contextual things to help set a scene. So we could then define event, incident, problem and cause in terms of those things. So we had to put some, again, as we said, not defining terms with undefined terms. So it's important to get a base. And then we've sort of added other things, detect, alert, notification, alarm, transient and intermittent as other things that start to help define. We've gone no further than that. So the central ones are the middle bullet, incident, problem, cause, are the critical things. So do take a look at the definitions. I assume you've looked at them. If you don't like them, shoot us and we'll change them. Okay, so but critically, we think it's important this gets adopted as a draft so we can actually work on it together in the group, keeping it separate from the other documents so it doesn't get mingled up with the stuff that is using the terminology. So a good terminology document, and then we can use that. So we decided we didn't think it should be merged. We think it should be a standalone document. So anyway, that's all I had to say. Something in the queue.
Yeah, thank you for this. I've not had a chance to read the document yet, but I think what you're doing here is a good idea. So I think I'm supportive of the effort. I think that's a good thing to do. The only concerns I have are really about wanting to know which other groups are also defining terminology. Is it just TMF or is there other people as well?
There'll be others too. So we just happen to have picked those as a starting point, and there'll be others we need to sort of sweep up probably where we're going to take work maybe from those other groups. So it's important. It's especially important if we're trying to bridge with those other groups, I think. I mean, because there'll be obviously the term will be all over the place in other industries, but that's not important for us potentially unless it gives us good insight.
And so that's going to the chairs, I think, a liaison statement to these different groups to say we're going to work on, if the consensus is to work on this, I think we should tell them early that's happening so they know at least. So that I'm keen on doing. And then the last
knowing
one,
the list is important because I don't know what I don't know, right? So
that's right, yeah.
So if you could help with that, Nigel and Chin.
Yeah.
And then the last comment I got is about timing. So sometimes it feels like these terminology documents can take a long time to settle, and I don't want the working group to spend years working on this, and it sort of delays other work. So in some senses, getting sort of reasonably good definitions early on and
Yes.
quickly,
Yes.
and then also refining the other work and refine the definitions as that work progresses.
Yes.
So maybe this can sit as a working group document for a year or two or something, and we think it's pretty much done, but it's still kept open to tweak it until
That
finally
makes
saying
complete
now we're ready
sense.
to go.
Yeah, it runs in parallel. We gradually refine and then document. It's a sort of a cycle between the documents. We refine the definition, refine the documents, refine the definition.
Yeah,
It doesn't stop the work. No, completely not.
and the only issue with that is in terms of dependency, publishing other documents. That's the bit where it gets a bit trickier to do.
Okay, thanks. Thanks very much.
Thomas Graf. I think it's really good work. I think it will help us a lot while we are writing other documents, that we can use the proper terminology. Maybe if you could go to the slide before.
Possibly.
Basically,
Yes.
my only comment was on the mailing list to find the term symptoms. That would clearly make then it's clearly easy to understand what anomaly detection is detecting. And maybe not limit yourself just on resources. It could be any state change in the network within the observed or outside the observed domain.
Yes.
Exactly. But otherwise,
we did have a lot of other terms before we paired it back to this. So happy to expand it, but not too far, because of course each term adds further complexity to the problem. So if you can.
Thank you very much.
Okay, thank you.
Mahesh, I just did a quick search on the draft to see if the word anomaly detection was defined or not. Since we're talking about anomaly detection in the other draft, we probably at least want to include it in the definition.
I agree entirely.
So Nigel, I want to make sure, because in OPSWG there's a packet discard draft. So I'm not sure whether this is in the scope of the terminology draft.
Okay. That's good. Good point. Thank you. Okay.
Thank you.
Thank you.
So a couple of things. We have to acknowledge there is a strong support in OPSWG for your document here. Now, what we have here is a new work item where actually the three things are correlated. There is, first of all, the terminology. The first thing was checking is symptoms, exactly like Thomas, because sometimes it's a false positive. You don't know if it's a right incident or right anomaly. I'm not too sure any longer, right? So, and that also clarified that in all discussions here, people use different terms. So the terminology is very important. The question by Mahesh, the relationship between, an anomaly and incident. So this is why we believe that this is like a package of three different drafts that should be linked together. So what comes from an anomaly with the right term and detection as well, Mahesh, should go to an incident whenever you show for sure, whenever you know for sure. So we believe that those three should be the author of the three drafts should be working together. So you propose a design team. This is a brand new working group. We're not such in a favor of design team because we want to see how the people will self-organize in the team, right? In the mailing list. So feel free to reach and work together to get those three things together working. And on the liaison, this is a good advice, Rob, that maybe we want to send liaison on the incident, which is higher in the NMS OSS, so sometime done by different SDOs. Did I summarize what we said correctly? All right. Rob.
So that all sounds sensible to me. So one question I have is, we talked about detecting these incidents and categorizing them and managing them. The next step to that is actually obviously then what action do you take to recover from them and resolve and things like that? Is that in scope in terms of what you want to work on now, or is that like a next phase thing, or is that?
This is the foundation work for the next step, I believe.
So at the moment, we're going to focus on just these things, because again, with the terminology, then again, there's a whole set of terminology about how you describe these actions you're taking, that sort of thing. So if at the moment we say we're going to restrict it to this, and I'm pleased and happy to say, let's keep it smaller now, make it a solvable problem, and then do the next step after that. Iterate.
So you've got a good point. So we do all this to do closed loop in the end,
yes.
Right? So your point is that do we want to go in a terminology that was going to address this directly? This is your point, right?
Yes.
It's open for discussion. Yeah, that's a good point. Nigel, any?
I fully agree with that. I mean, as you say, the closed loop's the critical thing at the end of the day. So
Get closer to the mic, please.
sorry, closed loop's the critical thing at the end of the day. So I mean, and there are n levels of loop here. So obviously, very large, long-range loops where you're refining the definition of the service itself. There are very short-range ones where you're fixing an immediate, urgent problem, and so on, and all sorts of stuff in the middle. But the closed loop thing's the critical thing. And as Scott said to me, whispered to me, it's fractal as a problem as usual. So each thing feeds the next level. So an incident at one level could be an input to the next level, essentially, of incident analysis and so on. So,
right. You're still in the queue, Thomas?
Okay. Not on purpose.
Not on purpose. So, Olga.
Hi, just question, Nigel. Sorry, was it intentional just to have resource, or did you miss the service intentionally to avoid the discussions like TMF resource versus service? Or?
Partly, yeah. We actually had service, and as I said, we had, I don't know, 40 or 50 terms initially, and we cut it back, and we just decided this level was the best level because the problems tend to occur on the resources themselves, and then they affect the services. But we thought the critical thing here was that the incidents and so on around resources initially. We can add service in, but we decided to keep it out at this point, to keep the list down.
Okay, thanks.
Okay.
All right, very good. Anything else? No. Thank you.
Thank you.
So the next topic is issues related to deployment and usage of Yang topology modules. So what we try to achieve with this session is to clarify the problem to be solved and the next step, how to structure this work. So this is a combined session, and I believe we've got Oscar first and then Olga second. So Oscar, do you want to start? We just pass the slide control to you.
Okay. So let me see. Can you hear me properly?
Yes.
Okay, so go to the next slide, please.
You have the control.
So, okay. Just I'm with the phone. Just 1 second. Yes.
Okay, so let's take the control back.
Yeah. I have it. Yes. I have it. I have it now. Okay, so here, first of all, I would like to clarify for the session today, which is the problem that we are trying to solve. Okay, so here, first of all, what do we try to achieve? Okay, so here, the main goal is how to represent a real network. Okay, so for example, our IPMPLS network here, just to limit a little bit the scope in Yang, especially with based on the IETF topology. And why do we want to do it, and what are the use cases that we want to achieve? So one of the operations that the network operator does yearly, for example, is the capacity planning of the network. So for that, you need to have this representation of the network. Also, run these what if scenarios or what if analysis. So, okay, what happens if I change some configuration here or there? So, for example, what happens if I change the weight of a link, or what if I add more capacity on this link, etc. Okay, and the ultimate goal, okay, that we think it's the ultimate goal of this work, a digital twin. So the ultimate goal of a digital map is, okay, I have the network represented in Yang, and that fits a digital twin where I can do even more complex analysis. Okay, so that's the ultimate goal here. Okay, so in order to not to boil the ocean, okay, so we started the work with a more, let's say, a more limited scope. Okay, so the first work that we did as part of this digital map is representing a network based on IGP domains. Okay, so it's how to represent this network divided into domains and where the flooding of the IGP is confined into this domain to use it for planning and simulation. And for that, for example, we have two documents. One of them is already published in NMOP, and the other one is going to be published soon as NMOP also. Then here, what were the problems that we encounter? So first of all is here the topology models. Okay, so here yes, we have one base topology model, but then we have if you see the young impact of the IETF topology model, there are tens of models. Even I was going to say hundreds, but maybe it's too much. But tens of models that augment the base one. They cover in many cases very technology specific details, but not only technology details. For example, okay, yes, okay, of course, one model can cover optical details. Okay, that's perfectly fine, but also they cover generic items. So some of them are focused on traffic engineering, other ones they cover service attachment points. So there are also interesting concepts found in other draft rather than the base topology model. Okay, so then you have to search across all these models. And what is when you try to model a network or a real network, you find that okay, most of the things that you want are found in several of these models. Okay, so you need to pick from here, from there. Also, you find some gaps. Not always is you find it what you want there, and also the way that everything goes to the base model, the RFC 8345 model, forces you to model everything in a particular way, and sometimes you require to do some hacks in the modeling just to make it work. Okay, so that we will see later those hacks that need to be done to the topology. So, for example, in this particular case of the ISIS, I'm not going to enter into details, but one of the main things that we wanted to model is how to model domains. Okay, so and what is a domain? Really, the domain concept, for example, is an abstraction. Really, it's something that we have invented ourselves. So we have defined what is a domain, and where okay, so some key feature of the network is confined there. So, for example, here we said okay, in an ISIS, it could be the area, for example, or it can be we chose as to have it there because it was like our decision is the flooding the flooding scope of the protocol, so that even can contain several areas. But this was the key characteristic that we wanted to model, and we say okay, this is a domain, and then what is a domain? Well, then representing in the network, it can be an instance of the IETF network. And then you can have, for example, one node belonging to multiple networks. Okay, but that, as I said, is an abstraction. Okay, so with this, Benoit, I think I have just finished the problem space from my side.
Thank you
And
very
if you
much.
have any
Scott.
questions, feel free to ask them.
So we'll have question. I believe that Olga is presenting the second part of the slide deck, and we'll have Q&A just after.
Okay.
Okay. Hello, everybody. So these are we did some experiments about the drafts that Oscar was mentioning, and ISIS experiments. We also did OSPF, but here I'll just mention ISIS. And like I won't repeat, but what Oscar mentioned, but the reasons kind of why the models were not, we could not model domains as networks. You know, the problem was that you know we couldn't get really the proper topological model because every application would also and have to look into the attributes and to understand the IS topology. ISIS topology was not defined through the entities and their relationships. It was defined inside the attributes themselves. So really the model itself didn't represent topology. The next experiment we did some augmentation to RFCA 345 and we modeled the areas network, and then we noticed that really the model that we got represented the proper topology as it is in all the documentation in the manuals and as we understand the how the things relate, network domains, etc. So this is just experiment that we did on the drafts using the drafts that Oscar submitted. The limitations during the experiments and the POCs that we did, and we didn't do just these two IGP protocols, we did more than that, and we identified, let's say, 7 categories of things. The first two bidirectional links and multi-point connections, and sorry, I forgot to mention, we did kind of submit a draft, that digital map draft that talks more about and describes all of these limitations and gives more information for those who are interested. So the solution for the first two gaps that we identified, bidirectional links and multiple connectivity links in RFCA 345, there are some solutions proposed in Nigel's draft, and currently it's OPS AWG draft for some refinements, but it would be moved to the NMOP. And Nigel is there in the room, so if anyone has any questions, please ask Nigel. The next three we identified during the experiment with Oscar's draft and also the other draft. I don't know, Oscar, I say here to be moved to NMOP. It will probably be submitted to NMOP after this after the meetings. And the last three, we also noticed missing some supporting relationships between node network, link network, TP node, and some semantics was not there. It was in the different augmentations done differently, but not in the core model. The way how you can potentially add roles and of the entities, but also maybe some resiliency, which could also potentially be modeled as a role. So we looked at on these gaps, we identified some candidate approaches and came up with some proposals for going forward. So I won't go into the details of candidate approaches. If anyone is interested, you can look at in the draft. The proposal that we have is to start to work on RFCA 345 bis to provide a backward compatible model to support all these limitations. And for first two, because Nigel's draft already covers the proposal, even two options, we propose to start from the basic backward compatible approach from that draft. And then also to evaluate all the other implementation inside the current augmentations for simplicity and if generic to use them to treat them as candidates for RFCA 345 bis. For 3, 6, and 7, meaning links between networks, missing supporting relationships, and some topology semantics, RFCA 8795 has some approaches modeled, so we should consider that approach for consideration. And for the option 5 nodes, TPs links, and for the gap 5 nodes, TPs links in multiple networks, believe it needs some further analysis, as it has bigger impact on the topology tree than other enhancements. But the core here is really that all enhancements will consider both current usage and will be backward compatible going forward, so that the current augmentations will not be impacted. We looked at the different augmentations, and as Oscar mentioned, tens or hundreds, there are 60 plus files, the 60 plus modules that are augmenting the two RFCA 345 modules. And then there are others which are augmenting those. So, potentially we have to go through augmentations of augmentations to be sure that we are capturing everything. But we started this analysis, and the first thing we did is we said, let's try to do some categorization. First, of whether those drafts are like, what functionality are they? Topological? Are they TE, PM, inventory? Are they generic or specific technology? And then the important thing is, what are they? What's the purpose of augmentation really? Is it to add new attributes? Is it to add new events, new relations? And then with question marks, topological entities. If there is a addition of the topological entities, in that case, the whole purpose of RFCA 345 to be able to explain the topology, the layer topology is not fulfilled really. So in that case, we have to see why it was done in the augmentation and to look at possibilities to do it maybe through the core or to discuss with other authors for the reasons. And also the last one is usage. Some of them are just using the types. So in that case, there is no impact whatsoever of any changes. So here are some challenges for multi-layer digital map, and examples here would be that let's say some of the topological entities are defined outside of RFCA 345 network node TP and link. For example, in the traffic engineering spec draft RFC, sorry, we have T tunnel and tunnel termination points defined not as links and TPs, but outside of it as a kind of embedded containers of the node. Then for Fabric as well, we have topological entities defined outside. Fabric is defined as a node, and then the ports and links inside the Fabric network, data center network, are defined as, again, contained containers inside the node itself, outside of RFCA 345 links and TPs. Then again, we have some underlay relations defined. We have some generic extensions, for example, for cross-domain links. The problem we're talking about different domains and links between cross domains, they're defined in augmentations. But are needed in other augmentations as well, potentially. So the consequence is that multiple augmentations would define it in their own way. And also some roles for topological entities are defined in these augmentations and custom made. The consequence for all of this is these augmentations are not consistent, and it will make it very hard to deploy the multi-layer digital map. So our goal would really be to achieve that all topological entities and relations for all layers could be modeled using the RFCA 345, and that augmentation should add some technology specific or some functionally specific attributes and properties, but not to change the core topology of the layer in the network. So what's next for us? The proposal is to start working on RFCA 345 bis to include the changes to IETF network and IETF network topology modules for the gaps that are identified in the draft, and to provide simple backward compatible solution to all identified limitations gaps. The proposal is to start from Nigel's draft for the first two gaps where he proposed a basic and more sophisticated solution. We are proposing to start from basic solution because it's backward compatible both for model for young and instances. The other one is just backward compatible for instances, not for young. Also, RFC 8795 is addressing some gaps and implementing some gaps, as I already mentioned, but also look at all existing augmentations. And we also want to do implementations of any proposed changes in the POC, and we will show the progress of the next hackathon at IETF and 20 of that POC. We also want to start working on guidelines for creating a digital map that would include finalization of analysis and categorization of all augmentations and which categories they belong to, and then as I already mentioned, these augmentations are not consistent at the moment, which makes it very hard to deploy it as a multi-layer digital map because any application would have to understand all the potentially properties or containers of the other nodes and networks. So you wouldn't be able to kind of do algorithms, generic algorithms on that, or do the visualization in generic way, or have API in a generic way. We also propose to have a meeting with TAS, to discuss their approach because they modeled tunnels and TTPs and underlay outside of the termination points and links and supporting relationships. So maybe we want to understand why they did it and maybe to see if some of these things could be moved to the core model. And thanks. It's 4 o'clock in the morning in Ireland, so I'm sorry if I was not clear in some points. Thanks.
I have to say it's 4 o'clock in the morning in Ireland after somebody's day. So
Yeah,
congrats for that.
exactly. Yeah, I have to take a limited amount of alcohol last night. Yeah.
Italo?
Thank you, Italo Busi. Okay, good that you are starting to think about A795. Thank you. I would like just to mention that in principle, there is nothing that precludes using 8795 over non-T networks. And I suggest to investigate this option because by doing the same augmentations everywhere will be easier to avoid inconsistency between networks where you have only T or network where you have only non-T or network where you have a mix of T and non-Ts. We have the same approach on every layer will be much easier. So, and then I support having this joint meeting with T. So it will be better to explore all the details and see to what level the gaps we identified are already addressed by 8795 and can be reused in this context.
Yeah, thanks, Italo. I think why we started from RFC 8345 and not from RFC 8795 because we are looking for both T and non-T, but also we were starting from something that is as simple as possible, and then, as you know, RFC 8795 is a quite complex, comprehensive model and with a lot of traffic engineering details.
So thanks, Rob Wilton. Thank you for staying up later presenting, so being in the middle of the night. So I just want to sort of process comment or question here, because obviously RFC 8345 was originally standardized, I think, in I2RS, which was part of the routing area, and the proposal, you're proposing to do a BIS document here in ops, which I think is the right place. I think it's the right working group to do that. So there just needs to be some coordination with the routing ADs. I obviously go throw Mahesh under the bus here as a new AD. Sorry, Mahesh. So I've quickly asked the routing ADs. I've had a read back from one of them. They think that with some coordination, that should be fine. So I think at the point that we get a draft and then we think about adopting and at least flagging like to RTG, WG, Ts you mentioned here. I don't know if there's some an ISIS and OSPF related ones, but again, obviously an LSR. So I think we should do some coordination early on and at the various phases, and then I think we should hopefully be good. And I'll leave it to Mahesh to coordinate at the AD level because I don't do that stuff anymore.
Can I reply to
Yes,
Olga?
Italo, yeah.
Okay, yes, I agree. 8795 are please very complex. However, if we start putting all the requirements that you need to address, I don't believe you will end up with anything simpler than 8795. The problem is the number of the requirements that you are putting together. Of course, if you stream down a subset of the requirements, you can simplify the solution. And that's why in TIS we are working on a profile. You can take a subset of 8795 if you have a subset of requirements to address, rather than having different models according to the different subset of the requirements. And the other point is I always see this issue. And Oscar before was mentioning, oh, there are so many models now. We have 8345 and we have a lot of augmentations. We don't know how to use all of them. So there is always a trade-off between many augmentations or a big model. And there is no perfect solution.
I can maybe leave Oscar to say something about that. Like for me, also one thing to think about is backward compatibility. So if you would use 8795 as a core topological model, then all the others which are augmenting from 8345 wouldn't be backward compatible for all of those. But maybe Oscar, you want to say something?
No, just about the main or the traffic engineering model. That I believe that many of the concepts there are or would be applicable as a core model, because I mean one of the things that we want or that require to model this relationship between layers, etc., are there, are in the T model, which are, let's say, applicable for layering, not just traffic engineering. So I don't know what is the perfect solution, but because the perfect solution might be to have a core model which incorporates these concepts there. So then you would have the T model to have only the T specific things. Okay, but it was not done that way. Okay, so this is why I worked also many years in the T topology model, and it was done as augmentation or because of that. But I believe that many of the core models or the core not model the core ideas can be brought into a common base model. Thank you.
Thank you, Oscar.
I just wanted to quickly respond back to Italo. So one of the comments you made about was whether having a large base model or lots of augmentations. I think having lots of augmentations is quite a good way, gives you flexibility. But I think one of the comments made earlier was that these augmentations aren't all working together and nicely, that there's inconsistencies between them. So that's something I think that IETF, if that is the case, we should be trying to resolve that and get to the point that the augmentations can all work together in different ways.
Yeah. Yeah, I think just to answer to Rob, that's why we are doing all this classification to understand what augmentations are for, because some of them are really for linking to, let's say, for inventory. The inventory topology draft is to link topology with the inventory, with the new IV inventory. Or we have the PM one, which is adding some statistics and performance management KPIs and metrics to the topology model, but others are doing technology specific augmentations, generic ones is SAP and it is traffic engineering one. And there are kind of some generic ones like VPN, PM for VPN's generic, but it's still at the services layer. So there are a few others maybe which are generic for relationships, but for the core topological one, I think they are the main ones.
And one last comment here is this: one of the exact purposes of this working group is to be trying to deploy this technology and find out what stuff isn't working together and what bits are break and those rough corners, and see if we can smooth those out and fix those things. So I think this is good stuff.
Thanks.
Daniele Ceccarelli, a quick comment. So you said that at least for the moment you are keeping 8795 out for two reasons: because it's complex and because it's T. The complex thing can be arguable, but please consider also the fact that 8795 has a lot of non-T stuff in it. That's important. So don't exclude it a priori. There were a lot of non-TE things that needed to be added, and it was taken the decision to do it in 8795 and not to do yet another separate augmentation. So probably some of those things could be worth being analyzed there as well. And the second thing, I really like that you stressed the simple backward compatible thing. Because probably this is more a question for Nigel. I've seen some augmentation that might or might not be backward compatible. This is a separate discussion, but please be aware that 8345 is very widely deployed now. So please keep in mind that the backward compatibility is extremely important now.
Yeah, Nigel, you can maybe have a chat in the room afterwards, but I think what Nigel has in his draft is fully backward compatible.
I want to answer to call a comment on backward compatibility of 8795. I don't think there is any issue because 8795 is adding an attributes to 8345, and there is nothing that precludes to instantiate 8795 augmentation together with the existing augmentation of 8345 at the same time. So by doing what we call multi-inheritance, having two augmentations together, you can take the attributes from 8795 that you need and the existing attributes from the non-T technology-specific augmentations at the same time. So there is no need to rechange those models to use them with 8795.
Of course, for the attributes, I was not thinking, because I don't think the issue here is the attributes. The thing is adding topological entities, So if you have some layers modeled in the core and some layers modeled in the augmentation, or cross domain you model in augmentation, but single domain in core, and then existing drafts or RFCs are augmenting the core, but not TE.
They are not augmenting those drafts are not augmenting the new topological elements. And if you need to augment the new topological elements, you need to upgrade those drafts. But if you create new topological elements over 8345, you have exactly the same issue. You have to augment the new topological element. The problem is that the existing augmentations, which are augmenting the 8345 existing topological elements, still works even if you use 8795 together. And if you want, of course, if you need to augment those new topological elements from 8795, the existing model needs to be updated to augment also 8795, but that's backward compatible because
you're right. It's not about backward compatibility. I was thinking more in terms if they need to add the feature, the node, they would have then to go through, the whole understand draft and learn from there.
Okay. Thank you all. I think that the key message is the one that Rob mentioned about getting all these Yang models to work together. I've been involved in Yang, and somehow in the IETF, we're known to have independent Yang modules. I believe this is our chance around topology, or call it digital map or whatever, to get all these Yang models based on the experience to make them work together.
Yeah, exactly. Yeah. So thank you again, Olga, for structuring the next steps. I think that you have a clear plan for them. So yeah, just last to exercise it and the step by step.
Thanks. And this is three of us discussed it. And if anyone has any questions in the room, Nigel can answer all of them. Thanks.
So the last part of the charter is the update on RFC 3535. So we don't call that 3535 bis, right? Because it's an IAB document. And okay, so Luis.
Thank you. So this is Luis from Telefonica. I will present the document on behalf of my co-authors, Matt, Thomas, and Oscar in remote. So let's go for that. So the reason of proposing this this internet draft was basically what the Rob commented before. The RFC 3535 was produced by IAB after a workshop on network modeling protocols and network management models and protocols. So 20 years ago, it was released in 2002, and this was somehow a catalyst of all the activity that we have experienced during the last years. So it was a catalyst of NetCon, Jan, all what we have been discussed so far along today. So this incentivized the work on, and many protocols were boosted after this effort. NetCon, RESCon, the Constrained Application Management Interface, and so on so far. Jan also has been prevalent on all these ideas of modeling the network. We have discussed a lot today, so this is evident, and has been a fundamental piece for the network automation process. It's maybe not the unique one, but a fundamental piece of network automation. However, after these 20 years, it's time to revisit the result of all this effort and essentially, check where we are, right? So understand what is the reality check in terms of deployments. So how far we have gone in the implementation of this in real networks. What has been the obstacles for doing that? Also to refresh the deployment assumptions that were conceived at that time, and to do the contrast with the real operations nowadays. To understand as well if we have new requirements coming from new kind of services that we are facing now. Also during these 20 years, the new services have been emerged, have been integrated in our system networks, aspects that were not considering at that time, different technological aspects, and so on and so far. I will not enter on details, but we can comment. And as well, to assess if there are yet some blocking points, or what are the blocking points that we are facing, because there are always blocking points. This is unavoidable. So why taking this into NMOP? Well, when Rob was presented the different charter items, there was this item on considering revisiting or updating this RFC. So this is a perfect fit for this document, and this is why we are bringing here today. What is the proposed approach that we are following on this? So this is not a BIS, Benoit just commented, so we cannot do a BIS from a document that is from the IEB. We can maybe, at least by now, consider this as a kind of second stage. So we are organizing the work in three main aspects or areas or tasks. One of them is to assess the recommendations of RFC 3535. So I understand what was conceived at that point in time, and now what is the reality check on this. Also to collect observations from the aspects that we are living today in the operational networks. Thomas elaborated a number of them. There are some others as well documented in the draft. So basically collecting the situation today. And then propose new requirements or new perspectives on the network management topic at all. We welcome the contributions for sure, so please feel free to approach and provide your feedback. So sample observations that are now collected in the draft. Clearly, and some of them has been commented along today, but well, let's go in a fast check of them. So nowadays, the current device models the ecosystem is very fragmented. We have models in IETF, in OpenConfig, in ONF, now Linux Foundation. So we have a variety of them in different bodies, and these fragmentations somehow create difficulties on having a unified approach to all of them. Despite the fact that the service network models originated in IETF are somehow implemented and adopted, this is not the case for the device model. So we are seeing somehow an unbalanced adoption in terms of models, and this also creates difficulties. There is intrinsically to the way in which we are working a long time for producing the JAM models in general, but also in particular for the device models. This is somehow creating that kind of gaps that from other venues are somehow covering and producing the documents or the models faster than us. Okay, this an observation as well is the fact that there is a prevalence of proprietary JAM modules. Also, in some cases, the usage of CLI. So old-fashioned approaches that somehow are difficulting as well all the automation tasks that I referred before. There is a lack of agile process in general, and this slow down the adoption in general. Problems with the complexity of integrating data was mentioned by Thomas at the beginning of the session today. Also, poor performance in data manipulation of the YANG structures because of the nature of the YANG structures. Not yet clear aspects like the translation between service network models and device models, and other facts as inconsistent data structures and so on and so forth. So a number of observations that resulting of the effort of integrating these network models in operational networks. So by now, what are the candidate directions of work that we are considering, we are having in mind? The first one, to rationalize the device models space and avoid the redundant efforts. As said, there are other venues that are working on models, so probably will be convenient to have a clear guidance for the development of the device models in IETF. Also considering more agile processes for developing YAM modules, maybe with reconsidering somehow the fact of documenting everything on RFCs, on documents that take so long, and probably finding another scheme, another way of producing these YAM models in IETF. Working on more profiling, so how to use the different pieces, the different augmentations and so, creating this kind of suites of models, these kind of profiles that could somehow simplify cases of deployment and somehow preventing a kind of best practices, or I don't know how to call it. So proper ways of using and deploying the YAM models. And finally, reassess the value of some of the IETF proposals versus competing approaches, like here there is the example of gRPC versus YAM push. So considering these kind of situations where we could have the alternative ways of doing the same thing or similar things. So next steps. We for sure welcome more contributions. This is a kind of collaborative effort between all the operators and all the experimenters of the network management in operational networks. Also, check if there are other venues where socializing this effort, read meetings, LACNIC, APNIC, these kind of things, or also working with IAB on this. And just to comment, the questions, suggestions are more than welcome, and hopefully, we can progress this work all together. Thank you. I think that was all.
Yeah, Joe?
All right. My name is Joe Clark, Cisco. I think this is fantastic. I think it's probably overdue, and I can be very pessimistic, but I'm not going to be. I say that because I've read the draft, and you start out by summarizing where we are with respect to 3535. What has happened, and some of the things that you X'd over were the SNMP MIB changes. One of which being that it took too long to develop SNMP MIBs, or SNMP MIBs became too proprietary. And the same thing is happening with YANG modules. And in fact, in the NOC here at the IETF, Bill Fenner joked to me the other day, oh, well, I just used that old SNMP thing. And one of the things that I think you talk about direction, where I think this would be great to go, and though I don't know if there's going to be enough teeth in this to make it happen. One of the things that I always saw when I was supporting network management at Cisco in our TAC, the weakness was there weren't any applications that, for example, did SNMP v3. Everyone was still using the old V2C, V1 stuff because it was there. The application supported it. And the same thing I think is now true here. I mean, we see like Thomas doing I think some bespoke work around YANG, but what we're really not seeing is an ecosystem of, here is an application, like we're using Libre NMS now in the NOC. Here's an application that can make use of this data in a very practical way, make use of network instrumentation, telemetry, whatever, in a very practical way that gives you the insight that you can get with traditional, I say traditional, maybe that's a bad word, with classical or older network management applications that already exist. So people go with the default route. And what I would love to see come out of here is maybe some suggestions of libraries, suggestions of implementations that would help either the open source community or vendors to say, this is how you could be using these new capabilities to do better. And I know, Benoit, you've been very vocal in the past about getting more Yang module development in a more agile way. I think that's fantastic. More of that drum should be beat. To say we need to do a better job at getting standards-based modules out there that are augmentable, that come out quickly, and encourage vendors to say, well, we could define our own, but why not just augment a little bit, a little here, a little there, into some that are standards based, and not wait forever for a module to appear from a standards body that other vendors, operators agree to. So again, I love the work. I'm happy to help. I think really what's going to help is showing real practical use and getting the complete ecosystem around using these capabilities and making it easy for people to go with the new and the hot as opposed to what's been working in the old.
Thank you.
Yeah, in addition to class comments, I think, compare with OpenConfig, best practice, they define a lot of grouping, actually reuse the grouping rather than, simply, rely on the, augmentation. Maybe this is something we should think about. Also, for this work, I think it's good work, thanks to kick off this work. Actually, I think, definitely, I think it's time to revisit the requirements and, but my question is, what should be the audience for this draft? Network operator, network vendors, and test equipment, center, and maybe OSS vendor. Actually, one observation is for Intech, multi-vendor interoperated test. Actually, they already engage in a lot of vendor to really, test the netconf young. So whether we can identify the requirements or some gap, over there. Yeah.
So my answer, I think probably impacts on to all the community. For sure, the practitioners of the models or the operators clearly is the audience, but also because we are somehow trying to identify requirements and recommendations, so probably it's broader to all the community. I mean, but probably the main, the principal target right now probably could be the operators, I think. But at the end, impacts everything because we will revisit everything.
Yeah, thank you.
Sorry, I missed some of your presentation because I was trying to multitask and failed at the same time. So I've looked at the slides and things, but the questions I have are really about sort of outreach and the scope of this work, because I think this could turn into a really big thing in terms of what you're looking at. And I think it's how you sort of scope that down or decide how you focus on that. I think the other question that I have is in terms of, do you want to reach out to a wider operator community? And if so, who's going to do that and how's that going to happen? Is that going to be via the IAB doing an outreach? Is that going to be NMOP doing something, or people going to Nanog and RIPE and things like that? So what's the scope of the people who are going to feed input into this? Because I think some of like the smaller operators, as I understand it, are not using Yang at all. They're just doing scripts and screen scraping and CLI stuff because that's what they've always done. They've got the scripts and they're sort of way outside the scope of that versus some of the operators who come here, much bigger operators and things who have a lot more flexibility and ability to actually create solutions and things like that. So I think it's different sets of operators that have different views of how relevant this stuff is, and it's how do we work out, do we care about all of them or the ones that come to IETF, and how do we outreach to those? Is IAB involved in that? Is it just us? Lots of questions here, and for Mahesh and the chairs.
Yeah, so very, very pertinent comments, Rob. I think regarding the scope, by now, this is our approach. Probably once we start, keep working on that, probably there could be the need of spinning off something to other document or whatever. Let's see. No, by now, we will start checking the status versus the previous RFC and trying to understand what could be the potential directions. And then let's decide if these potential directions maybe go in different documents or so. I would say that. And regarding the venues and the operators and so, our idea is to also try to engage other operators in these kind of venues, the RIP or LACNIC or AppNIC, these kind of organizations. How to do that? But I don't have the answer right now. But the idea would be to open up this effort to others as well, in order to collect the different views. It's probably the ones that we are here, probably we don't have all the vision, so we need to open up this to others. also IAB and so.
Because I think definitely reaching out is a good thing. And I mean, I don't generally go to those meetings. I went to one of the right ones, and I was really surprised that there was no sort of session at all on network management. I was just, it's like, how's this possible? I don't know.
Yes, Rudiger?
Well, okay, I'm a little bit cut off from current operations. And it looks to me like I'm the only survivor of that workshop who is actually present here. I would like to drop some remarks from that perspective. Quite clearly, you cannot do a BIS for a workshop. Actually, if you have trouble for getting to a well-cut document, you might actually resort to a workshop and just do the minutes of it, like was done back then. Kind of the situation right now, to me, looks very, very different from back then. The actual outcome was essentially the suggestion of doing netconf, or what turned out into netconf, and all the things that have come later, like Yang, were kind of looked as something as a very futuristic suggestion. So things are looking quite nice at that in that respective. What we had back then was that there was actually a disconnect between the network management people and the operators. And a slightly nasty way of saying what was the objective of kicking off that workshop was that the operations AD was going to teach the management AD that SNMP was not really sufficient for doing everything. And kind of one of the suggestions from my experience is, yes, you have to really keep avoiding a gap between a cloud of people doing network management systems and operators that are actually remote from them. And towards Joe's comments, yes, I think, and that's certainly a problem, that one has to address certain levels of operators who actually need to have different tools, or, well, okay, maybe in the end, looking into the technical details, it may be the same tools, but it may be different levels of language and complexity to actually interact with the tools. So good luck. And actually, things look much nicer today. Back then, I was thinking, oh, will I in my lifetime actually see the results of this workshop? And I have been overwhelmed.
Thank you. I have a clarification question. Is this work only about netconf and, as was mentioned, the consequence of netconf, which are resconf and Yang, or there is more to it? So let's assume that the operators are telling, oh, I want to have AI-ready networks or LLMs-ready network now. Is this in scope of this work? Is this the focus is just Yang or bigger?
My personal comment, I think that the focus is automation. Yang is the tool that we have for automation today, but probably could go maybe to something else. I don't know. But I think that the focus is automation and playing with the tools that we have, with the experiences that we have, and with that derive maybe needs for.
All right. Because whenever Chin asked the audience for this, I was asking actually the reverse question. Which inputs, what are the people for which we need to ask the input information. And to come back to your point, Rob, I mean, I don't believe that we've got enough operators here to give the right requirements, because we've got the requirements from the operators here already. We've got this brand new NMOP working group, right? So I believe we need to reach out with an IAB workshop and to RIPE and to NANOC and to see what are the next big thing. And I hope it won't take 20 years, but it depends which requirements you want to tackle. Is this Yang only or the thing after that?
No, I would say the point is the automation, like I said. So right now, Yang is what we have in our hands. Probably could be something else. I don't know.
Yeah, well, okay, kind of. It is really nice to have Yang and ongoing work for actually mapping the reality of the networks into it. But kind of what is finally the thing that has to be used is tools. Yang is really nice, but it is only something, well, okay, it's not the goal. It's actually a tool for something better.
And that will be the conclusion of the survivor of the first workshop. It's 3 p.m. We would like to thank you all for participating. And let's start and let's keep working. Thank you.
Thank you all. Je te dis ce truc-là, il faut lancer, il faut pas. Après, il faut voir comment ça va, vers quoi ça va mener.